Okay, today we're going to talk about example 8.3 analysis of Hall container system. So to understand what's Hall container, to solve this question, we have to know what's Hall container system. So Hall container system, there are two types. So there could be a conventional mode or an exchange container mode. So today we're going to look at the conventional mode, okay, for Hall container system. So in the morning, a garage will come. A truck will come from a garage to the first container location. So it will pick up the first container. That's the time required to pick up the container. We call it pick up container, PC, pick up container time. And then the container will be carried by the truck, to the disposal site or transfer station, and then go back to the original container location. So that's a name for this. They call it as a haul time per trip. Okay, haul time per trip. Haul time per trip. So we have a PC, we have a haul time per trip, and then put back the container at the first container location. This is what we call UC time, unload container time. All right, and then it will drive to the next location, the second location. This is called drive between location. So DBC time. Okay, DBC, drive between container time. There's also a name for this. Let me check. So DBC, okay, this is DBC is time required to drive between container location. It's hour per trip. All right. Okay, so let us look at the problem. Okay, before we start with the problem, you also need to know that there are two tables we need to use. Table 8.5, where we will get the PC time and UC time, and also the time at the site. Okay, and the figure 8.16. Figure 8.16, we need it to estimate the haul speed. Okay, mile per hour. Right. So if we look into the problem, let's list out the information we can get. So if we look at this, you can, if we look at the problem, you could see that there is a garage. There is a maybe let's draw a diagram to understand the whole thing. So it is in this way. It is, you have a first container, okay, which is loaded. Okay, right. So we have a truck coming in the morning from the garage. Okay, so and then it would carry the waste to the disposal site or transfer station, and then drive it back to the first container location. All right. Okay, so the time to pick up the first container is in short we call it PC. Okay, pick up container. All right, and then the time to put back the container, you call it UC. UC is a time required to put back the container after it's being unloaded. So the time to travel, the haul time, this is a haul time. We call it H. All right. Okay. And H is let me see. H is actually given by A plus B multiplied X. Okay. So that's what H is all about. Okay. And then at the site, there is also a time. We call it S time. So when the truck pick up the container at the first location and bring it down to the disposal site, and you want to unload the waste to the disposal site or the transfer station, there is a time required to do that. They call it S. Okay, S. So once the unloading is done, it will take the container back to the first container location and place it back, and then you have to move, the truck have to move to the next location to carry the next full container, okay, and then bring the container to the disposal site to dispose, and then bring it back. Okay, that's the second location. Alright, so this is actually the same container, just as this. These two are same container. So they bring the container to the site and put it back. So the container now from here moves to here. Okay, so it's the same container, only one container at one location. And this is the second container. So the full container carry to the site and send it back. Alright, so this two is the same container. Okay, and then of course after it's done, you move to the next location. That's called the movement to the next site is called DBC. Okay, drive between container. So we try to have a clear understanding of what all this what is this all about. Okay, so there's a name called PHCS, okay, which is given by PC plus UC plus DBC. Okay, and then there's another term called PHCS. It's a PHCS plus S, which is a time at the site, plus A plus B S. Alright, so this is actually the H. Okay, H is a haul time. Okay, PHCS is a combination of pickup container, means the time when the truck comes, pick up the first container, the time needed to pick up the container is called pickup time. Okay, pickup container time. And then haul all the way and then back. Okay, and then place it back the container to the first site. So you have UC. Okay, unload container, place the container back, the time to place the container back, and then drive to the second location. That's called drive between container. All right, and then the total time, the total time for the whole operation, you need to add in this PHCS plus the time at the site, the time to actually unload the waste to the disposal site. That's called S, and then add the whole time. Okay, so you see all the time are being added together. So you see the pickup time, unloaded time, unload container time, drive between container time, and then you have a H haul time and the disposal time. Okay, all right. So let's go back to the question again to understand what we're trying to solve. So you could see that let's read the question. Based on the traffic studies at similar park, it is estimated that average time to drive from garage to the first container location is T1, and from the last container location T2 to the garage each day will be 15 and 20 minutes respectively. If the average time required to drive between containers is 6 minutes, okay, and the one-way distance to the disposal site is 15.5 miles, which has a speed limit of 55 miles per hour. Determine the numbers of containers that can be emptied per day based on 8 hours work day. Assume the off-road factor W is equals to 0.15. So the objective of this work is to try to understand that each day when the truck comes, how many container can it empty before the 8 hours time work day is finished. So you can see that this whole thing as a one complete step of clearing up a container, right? So how many container can it empty? Okay, how many container can it empty? So all right, So let's list out the information. Okay, so we have to list out the information so that it will be easier for us to solve the problem. Alright, we know there's a T1 which is 15 minutes. Okay, so we divided by 60 minutes per hour, and then we should be getting 0.25 hour. And then there's a T2. Okay, so what is T1? T1 is actually the garage first container location. So what does it mean? It's an average time to drive from garage to first container location. That's T1. And T2 is time to drive from the last container location to the garage. Okay, so T2 is 20 minutes or 60 minutes hour. The reason we're doing that is because we want to convert it into hour. Right? Okay, and then we have the drive between container. The drive between container we are given here is 6 minutes. Okay, 6 minutes per trip. Right, we can convert it into hour by dividing into 60 minutes per hour. Right, so we should be getting what are we getting here? 0.1 hour per trip. Okay, 0.1 hour per trip. And what else we need to look at? Okay, and the round trip haul distance. Round trip haul distance, which is x, is actually taking 15.5 miles multiplied by 2 per trip. Okay, per trip. So we have 31 miles per trip. Alright, and we are being told that the speed limit is 55 miles per hour. Alright, and we are asked to find the number, okay, the number of containers empty per day, which is equals to number of trips. Okay, numbers of trips per day, and in short you call it ND. Okay, ND. Alright, we need to find out what is this value. Right, and we are being informed that the workday hour is 8 hours, and then the off-route factor W is 0.15. So what does it mean by off-route factor? Okay, let's try to understand what's off-route factor. Off-route factor is actually is to say that necessary off-route time includes time spent checking in, checking out in the morning and at the end of the day, or the time loss, or also include the time loss due to unavoidable congestions, the time spent on equipment repair, maintenance, and so on. Okay, unnecessary off-road time includes time spent for lunch in excess of the stated lunch period, and time spent on taking unauthorized coffee break, talking to friends, and other activities. So we can say that off-road time could be a lunch time, could be a breakdown time, okay, congestion time, and so on. All right. So we should refer to, okay, so we should refer to tail, frame, okay, mechanical loading method, okay, having stationary compactor. All right, so now we should get the answer. All right, so we have to refer to table 8.5. So let's look at table 8.5, see what kind of information can we get. Table 8.5. Okay, this is table 8.5. So we can see that the pickup container time, and unload container time is here. All right, and S time is here, as site time is here. So we should refer to tip frame, and also mechanical loading method. So we should get PC and UC time 0.4, S is 0.133. So this is hour per trip. All right, so let's write it down. PC plus UC equals to 0.4 hours per trip. And then we also have S, okay, at site time 0.133 hour per trip. All right. We've been told that the DBC is 0.1, okay, is 0.1 hour per trip, and then we should now find the pickup time per trip, which is PHCS is equals to PC plus UC plus DBC. All right. Okay. So this is a PC, UC, DBC. Okay. PC, UC, DBC. So the value should be these two given us 0.4, and this one given us 0.1. So we should get around 0.5 hour per trip. All right. So what other information can we get? So we should refer to figure 8.16 for 55 miles per hour. All right. So we know that maximum speed is 55 miles per hour. So with this information, we can find the haul, what do you call that? The haul time. All right. So let's check out figure 8.16. So we know the speed limit is 55. So we can find the A and B value. So the A is 0.016 hour per trip, and the B is 0.018 hours per mile. So just let's write it down. So A is equals to 0.016 hour per trip, and the B is 0.018 hour, sorry, is hour per mile. Yes, hour per mile. Okay, so now we can actually find the with this information we can actually find the time per trip for whole container system, which is known as PHCS. Okay, this is time per trip for whole container system. Okay, so which is this one. All right, we can rewrite the equation PHCS plus S plus H, and we know that PHCS plus S and the H is actually given by A plus B multiplied with X, right? So what is actually X? What is X? X is actually the average round trip haul distance in mile per trip. All right, so now we can write the whole equation as THCS equals to PHCS plus X S plus A plus BX, and you can write it as 0.5 hour per trip for PHCS. Okay, PHCS is this value. All right, plus 0.133 hour per trip for S. So the S is already found as this. Okay, and then plus A, which is 0.016 hour per trip, plus B 0.018 hour per mile, and then multiply with 31 mile per trip. All right, so the A, this is A. Okay, this is A, this is B, this is B, and then this is a total travel distance, which we already know. Round trip haul distance is 31 miles per trip. Okay, it's given here. So what's the value of this? We find out that the value is 1.21 hour per trip. Okay, this is what we get. And now let us look at the equation to solve this problem. So the equation to solve this problem is ND equals to H. H is the work hour. Okay, this is H. All right, H 1 minus W, and this is a W. Okay, W minus T1. Okay, T1 is here, plus T2. Okay, this is T2. All right. Okay, the whole unit is actually hour. All right, divided by THCS that we have just calculated. Right. So what's the value for this? Let's put in the so this unit, you know that is an hour per trip. All right. Okay. So let's put in the value for calculation. 8 1 minus 0.15 in the bracket minus open bracket 0.25 plus 0.333 close bracket. Okay, 0.25 is here, 0.333 is here. Alright, and then divided by THCS, which is 1.21 hour per trip. and the answer is 5. Answer is 5.14 trip per day. Okay, is it correct? 5 point, this is hour. Okay, this is hour. So let me see. Yeah, so you can go up to 5 trips, means you can settle 5, 1, 2, 3, 4, 5 container per day. That's what it means. Right, 5.14. So you cannot carry 5.14 container. You can only carry 5 container maximum. So it should be 5 trips per day. So take the container, bring it to the disposal site, place it back, go to the next container. So this is a complete trip. So we can only do 5 trips. 1 trip, 2 trips, 3 trips, 4 trips, 5 trips. So that's, then 5 trips means you can only do 5 containers. Alright, so that will be the answer for this. So I hope you all understand what I'm trying to do, and if you have any question, you can ask me. Okay, thank you very much.